The success of large-scale software-intensive systems is largely dependent on the engineering, management, and process capabilities, people, practices, methods, and tools of the enterprise, charged with requirements determination, design, development, testing, fielding, and sustainment of systems and systems of systems. Within any organization, these elements of success are in various stages of maturity, and their evolution and alignment may become the source of strategic software management and continuous process improvement. At any point in time, these gaps can be referred to as technical debt when they result in persistent reputation, economic, mission, or competitiveness costs and risks. When these gaps are neglected, whether undiscovered or consciously ignored, technical debt may be incurred and may even be revealed as software malpractice. Software malpractice can be pinpointed using the filter of technical debt. Technical debt is the organizational, project, or engineering neglect of known good practice that can result in persistent public user, customer, staff reputation, or financial cost. Shortcuts, expedient activities, and poor practice contributing to the initial product launch or initial operational capability are often cited as justifiable excuses in taking on technical debt. But in truth, most technical debt is taken on without this strategic intent, without even knowing it, and without the wherewithal and capability or capacity to do the job right. Using the paradigm of accumulated technical debt, the preconditions and leading indicators associated with management, engineering, and process can be evaluated as triggers in appraising whether a project can be completed satisfactorily or unsatisfactorily, and whether unsatisfactory performance rises to the level of malpractice. Wikipedia states, malpractice is a type of negligence in which the professional duty to act fails to follow generally accepted professional standards, and that breach of duty is the proximate cause of injury to a plaintiff who suffers harm. Injury or harm is associated with the buyer acquisition cost of the seller's products and services, lost opportunity to the buyer when the project fails to materialize, loss of reputation to the buyer for promises made to clients in expectation of a successful project, and cleanup costs associated with the rollback of buyers' preparation to receive and operate the failed system. Stated as assertions, the buyer-seller dispute questions include the following. The contractor performance is satisfactory. This question centers around readiness to perform and management and control of performance. The contractor performance is unsatisfactory. This question centers around lack of readiness to perform, lack of management and control of performance, and the accumulation of technical debt spanning engineering, management, and process. The contractor poor performance rises to the level of malpractice. This question centers around process management, project management, and product engineering. The contractor poor performance caused injury or harm. This question centers around acquisition cost, lost opportunity, loss of reputation, and cleanup costs. The project can be completed satisfactorily. This question centers around technical debt accumulation spanning engineering, management, and process. The analysis framework shown here highlights the industry methods and standards of performance for good software process management and engineering. The evidence criteria guidelines for readiness and performance reflect industry experience and practice for the methods and standards of performance for good software process management and engineering. The conditioning triggers for management are shown in the table. The conditioning triggers for engineering are shown in the table. The conditioning triggers for process are shown in the table. Here is my contact information. I would be happy to receive questions and have discussions with people on this important subject.